Chapter 5.1, the natural logarithmic function, differentiation. Day 2, derivative of natural log functions. If you remember antiderivatives, all right? You remember antiderivatives. The power rule for antiderivatives says x to the n you're going to power up. However, if we have x to the n minus 1, or x to the negative 1, and you power that up, you get x to the 0, and your next part is to divide by your new power. And you're dividing by 0. So as it turns out, the power rule for antiderivatives works for every number except for when your power is negative 1. And to deal with that, what we do is we define that as the natural log. So if you have x to the negative 1, or 1 over x, we define that as a natural log. So the natural log of x equals 1 to x, the antiderivative of that, of 1 over t with respect to t for x is greater than 0. And that's the definition of natural log. And if we use the second fundamental theorem and we take the derivative of that with respect to x, using the second fundamental theorem, we'll see the derivative of the natural log is 1 over x. And when we go from 1 over e, the derivative of that, you end up getting 1. All right? So the derivative of the natural log is 1 over x. If there happens to be a function inside of there, we end up doing the derivative of the inside function over the function. And that's just the chain rule. If you had the natural log of x squared, you could do the 1 over x squared, and then multiply by what's inside, or you could just do the derivative of what's inside over what's inside, or u prime over u, or du over u. All right? That's the derivative of the natural log. The derivative of what's inside over what's inside. All right? So to try a simplistic example, we can look at this one of two ways. The quickest way, easiest way, is to just take the derivative of what's inside over what's inside, and we can see we can reduce it. So the derivative of the natural log of 2x is 1 over x. Another way you can do it, which actually makes this problem maybe a little bit harder, not a whole lot, is we can apply our log properties to this. This is a multiplication of a log. We can split that to the natural log of 2 plus the natural log of x. And natural log of 2 is a constant, so that ends up being 0. And the natural log of x, we already said, was 1 over x. So we can see, looking at this two different ways, both ways, we get 1 over x. That's a good thing. In this case, expanding it using the log properties didn't make it any easier. A lot of times, though, you're going to come across a problem where expanding it's going to make it a whole heck of a lot easier. Okay? In this case, if we look at it, x squared plus 1, we can expand when there's multiplication or division in there. We have addition. So we can't expand this, so we'll just take it as it is. The derivative of what's inside is 2x over what's inside is x squared plus 1. Our next problem. Here we have the derivative of x times the natural log of x. This is a multiplication, so we're going to use the product rule. It's a little trip on the Wayback Machine. It's been a while since we've done the product rule. The product rule is the first function times the derivative of the second function, 1 over x, plus the second function times the derivative of the first, which is 1. And simplify it, x times 1 over x is 1, plus the natural log of x. And number D, or letter D, depending on how you want to look at it, we got the natural log of x, quantity cubed. This is chain rule. We got a function inside the function. So We're going to do the derivative of the outside function first, so that'd be 3 times the natural log of x squared, power down, times the derivative of what's inside, 1 over x. And you can simplify that, 3 ln of x squared over x. Okay? Now we come to where we're going to want to start using our log properties. If we look at this, the natural log of the square root of x plus 1, what does the square root really mean mathematically? Well, it means we want x plus 1 to the 1/2 power, and in our logs we take our 1/2 and we pull it out front. So we got 1/2 natural log of x plus 1. Well, this is a constant multiple. Because 1/2 is a constant, we can just take the natural log of x plus 1 and multiply it by 1/2. So we get 1/2 times the derivative of x plus 1 over x plus 1. We can leave it like that, or we can distribute 1 over 2x plus 2. Now, this is where it gets really exciting. The natural log of x times x squared plus 1 squared over the square root of 2x cubed minus 1. Right? First off, expand it as far as you can get it. Notice we got 2 products up top in the numerator and 1 product or 1 term in the denominator. Anything in the denominator will get subtracted. Anything in the numerator, any products, any terms in the numerator will get multiplied. And our powers, those become multiples of the log. So we'll split this to natural log of x plus 2 natural log of x squared plus 1. And then we do the bottom, minus 1/2 natural log of 2x cubed minus 1. Make sure you group your 2x cubed minus 1 because you want the natural log to act on the entire thing. All right, now it's just simply a matter of take each derivative. Derivative of natural log of x is 1 over x plus 2 times the derivative of the natural log of x squared plus 1. We'll do the derivative of what's inside over what's inside minus 1/2 times the derivative of what's inside, so that'd be 6x squared, over what's inside, be 2x cubed minus 1. And then simplify if you choose. We got 1 over x. Here, that 2 and that 2 will make 4. So that's 4x over x squared plus 1. Here, this 2 and that 6 will reduce. We'll have minus 3x squared over 2x cubed minus 1. All right, so in review, the derivative of a natural log. If you have the function y equals ln of x, your derivative is 1 over x. If you have a function, natural log of u, your derivative with respect to x will be whatever the derivative of u is with respect to x, or over u. Or we can say y prime equals u prime over u. And that's the derivative of the natural log function.